Let's denote the given number 3 plus root 7 raised to the power n as the sum of two numbers I and f, where I is the integral part of the number and f is the fractional part. Now since f is a fraction, therefore it will lie between 0 and 1. Therefore, I plus f is equal to 3 plus root 7 whole raised to the power n, which using binomial theorem can be expanded as 3 raised to the power n plus n choose 1 times 3 raised to the power n minus 1 times root 7 plus n choose 2 times 3 raised to the power n minus 2 times root 7 square plus and so on. Let's call this result 1. Now consider the number 3 minus root 7. Root 7 is approximately equal to 2.6. Therefore, the number 3 minus root 7 is a proper fraction, that is, it lies between 0 and 1. Now, a proper fraction raised to the power n, where n is a positive integer, is also a proper fraction. Therefore, 3 minus root 7 whole raised to the power n also lies between 0 and 1. Let's denote 3 minus root 7 whole raised to the power n by f dash. Therefore, f dash lies between 0 and 1. F dash is equal to 3 minus root 7 whole raised to the power n, which using binomial theorem can be written as 3 raised to the power n minus n choose 1 times 3 raised to the power n minus 1 times root 7 plus n choose 2 times 3 raised to the power n minus 2 times root 7 square minus and so on. Let's call this result 2. Now adding results 1 and 2, we get I plus f dash on the left hand side is equal to, on the right hand side, 3 raised to the power n plus n choose 1 times 3 raised to the power n minus 1 times root 7 plus n choose 2 times 3 raised to the power n minus 2 times root 7 square plus and so on. Plus 3 raised to the power n minus n choose 1 times 3 raised to the power n minus 1 times root 7 plus n choose 2 times 3 raised to the power n minus 2 times root 7 square minus and so on. On the right hand side, all the even numbered terms cancel out. And we're left with 2 times in brackets 3 raised to the power n plus n choose 2 multiplied by 3 raised to the power n minus 2 times root 7 square plus and so on. Now the expression in the brackets is an integer, and therefore the right hand side is equal to 2 times an integer, which is an even integer. Let's denote it by 2k. Therefore, I plus f dash is equal to an even integer 2k, and so f plus f dash is equal to 2k minus I. Both the components of the right hand side are integers, and therefore the right hand side is an integer. And so the left hand side, which is f plus f dash, should also be an integer. But we know that f lies between 0 and 1 and f dash also lies between 0 and 1. Adding the two inequalities, we get f plus f dash is strictly greater than 0 and strictly less than 2. But f plus f dash is an integer, and the only integer which lies strictly between 0 and 2 is 1. Therefore, f plus f dash is equal to 1. Therefore, the result I plus f dash is equal to 2k obtained earlier becomes I plus 1 is equal to 2k, which implies that I is equal to 2k minus 1. Now recall that I is the integral part of 3 plus root 7 whole raised to the power n. It therefore follows that the integral part of 3 plus root 7 whole raised to the power n is equal to 2k minus 1, which is clearly an odd number. And this is the required result.